Hello, everyone, and welcome to HNM Technologies online training program. In previous topics, we learned how to build, evaluate, and deploy machine learning models. However, building a model is only part of the story. In real-world environments, managing, deploying, and maintaining models at scale is much more complex. This is where MLOps comes into the picture. MLOps stands for Machine Learning Operations. It combines machine learning, DevOps practices, and data engineering to ensure reliable, scalable, and automated model deployment. Traditional software systems are deterministic. Given the same input, they always produce the same output. Machine learning systems are probabilistic. Their behavior can change as data evolves. This introduces new challenges such as model versioning, data drift, monitoring performance, retraining automation, and reproducibility. In production, we must manage data pipelines, model training pipelines, deployment systems, monitoring dashboards, security and compliance. Without MLOps practices, models quickly become outdated and unreliable. For institutions, understanding MLOps prepares students for industry-ready roles like ML engineer, AI engineer, and MLOps engineer. An ML pipeline is an automated workflow that moves data through multiple stages. First is data ingestion, where raw data is collected from various sources. Next is data validation, to ensure quality and consistency. Then comes feature engineering, transforming raw data into useful inputs. After that, model training occurs. Evaluation checks performance using validation datasets. Once validated, the model is deployed to production. Finally, monitoring tracks performance over time. Automation is critical. Manual steps increase risk and reduce scalability. Modern companies use CI/CD practices for ML pipelines, similar to software engineering workflows. There are multiple deployment strategies depending on use case. Batch prediction processes large volumes at scheduled intervals. Real-time AP is allow instant predictions. Blue-green deployment maintains two environments for safer upgrades. Canary deployment releases the model to a small group before full rollout. A/B. Testing compares two model versions to evaluate performance. Choosing the right strategy depends on business risk, latency requirements, and user scale. After deployment, continuous monitoring is essential. Model performance can degrade over time due to changes in data patterns. Data drift occurs when input data distribution changes. Concept drift occurs when relationships between inputs and outputs change. Monitoring systems track accuracy, latency, and data quality. Alerts notify teams when thresholds are crossed. Automated retraining pipelines can update models regularly. Without monitoring, deployed models become unreliable. In ML projects, multiple experiments are conducted. Each experiment may use different datasets, hyperparameters, and architectures. Model versioning ensures we can track which version is deployed. Dataset versioning ensures reproducibility. Experiment tracking tools record metrics and parameters. Reproducibility is critical in regulated industries like healthcare and finance. Without version control, debugging production failures becomes difficult. Machine learning systems must be secure and ethical. Data privacy laws require secure handling of personal data. Bias in training data can produce unfair predictions. Adversarial attacks can manipulate models. Transparency and explainability improve trust. Responsible AI frameworks ensure fairness, accountability, and compliance. Institutions expect students to understand these responsibilities. As user demand increases, ML systems must scale. Cloud platforms provide elastic infrastructure. Distributed training accelerates deep learning. GPU acceleration improves performance. Microservices architecture isolates components for reliability. Scalability ensures system stability under heavy loads. MLOps has created new career roles. ML engineers build and deploy models. MLOps engineers manage pipelines and automation. AI engineers integrate ML systems into products. Data engineers manage large-scale data infrastructure. Understanding production ML makes students industry-ready.